Okay, this section deals with differentiation. Chapter 1. Objective. Compute an average rate of change. Find the simplified difference quotient. As x approaches the limit of f of x is L, the net limit is written in that form. Limit of a at limit of f of x as x approaches a is L. This simply says as x is closer to a, x gets closer to L. So as the input gets close to a designated input, the output gets closer to a designated output. The thing we can use it for is to find the average rate of change over a particular interval. This also is known as the slope here. So we can see that the average rate of change between 2 points. The line through P and Q is called the secant line. It goes through 2 points. Tangent line goes through 1 point. This one here asks us to find f of x, find the rate of change. As x goes from 1 to 3, x changes from 1 to 2, 2 to 3. So here, the first one here, 1 to 3. The first thing I did was I wrote out my formula. The second thing I did was I assigned values to my variables. Here. All of this here. Assign values to my variables. Third thing I did was I plugged in to it. Then I simplified. Okay. So I wrote out my formula. Assigned values to my variables. Then I plugged in. Then I simplified. Now for number C, number B, 1 to 2. 1 to 2. So the first thing I did is I wrote out my formula. Second thing I did was I assigned values to my variables. The third thing I did was I plugged into it. Then I simplified it and gave me the answer. For, that was number B and number C for 2 to 3. The first thing I did was I wrote out my formula. The second thing I did is I assigned values to my variables. The third thing I did was I plugged in. And it simplified and it gives me the answer there. Definition of the average rate of change with respect to all x is called the difference quotient. It's given by that formula there, where h is not equal to 0. What's happened is that the same slope formula, except that they're describing all the input in terms of the initial input. So we have your x, your initial x. The next point would be whatever the difference is between those points. X plus h, the difference over. Okay. Hence the name is difference quotient. This one here we're looking at the slope of a secant line. In this case we're looking at slope over an interval. Example 2 here. For x squared, find the difference quotient. So the first thing I did was I wrote out my formula for the difference quotient. Second thing I did was I assigned values to my variables, x, h, f of x, f of x plus h. That implies that it's 25. From here, it implies that it's 64. Then the third thing I did was I plugged in. So I found my f of x plus h. Then I plug them in, and I simplified. That's my answer. The next one here, we have f of x is 5, and h is 0.1. Okay, so the first thing I did was I wrote out my formula. The second thing I did is I assigned values to my variables, my x, my h, f of x. Okay. F of h here. So after I've done all those things, set values to my variables, then I plugged in here. I simplified. Example 3. Find the difference for x cubed. So the first thing I did was I wrote out my formula. Second thing I did was I assigned values to my variables. Then the third thing I did, I plugged in. Then I expand this out. See the dx minus 3 is canceled. There's a common factor of h here, so I factor it out. The h is canceled. So after all that is done here, that's my answer. This next one here, use the result to calculate the slope-secant line, the average rate of change at x equal to 2, and the step value in this case is 0.1. Then the h is 0.01, 0.001. Point is, notice what happens when you let the intervals get shorter and shorter and shorter. So we get into a point where we can find the derivative of a particular point. Okay. So here I do that. X is equal to 0.1, it's 2, and I plug in. And I end up with 12.61. Then I let h equal to 0.01, x is 2. And I plug in. So if I get 12.06, so it's getting closer and closer to 12. To a point here. This is 0.001. So I plug in and I simplify. And I get 0.00. Notice how as the interval gets closer and closer. And there's a summary. Okay.